Yes, for 500 MCM conductors per phase will be sufficient for this installation. The calculated load is 1140 amps. The number of phases is 3. The ampacity of a 500 MCM THHN copper conductor is 250 amps, according to NEC Table 310.16. The total ampacity of 500 MCM conductors per phase is calculated as 4 times 250 amps, which equals 1000 amps. Comparing the total load of 1140 amps to the total ampacity of the conductors at 1000 amps, it appears that the conductors are not adequate for the installation. However, there is a safety factor of 25% built into the ampacity of conductors per NEC Article 310.15b2. This means that the conductors can safely carry up to 25% more load than their rated ampacity for a limited time. To apply the safety factor, the adjusted ampacity of the conductors is calculated as 1000 amps times 1.25, which equals 1250 amps. Since the adjusted ampacity of the conductors, 1250 amps, is greater than the total load, 1140 amps, the conductors are adequate for the installation. There are additional considerations. Firstly, the power company's requirement to run only 500 MCM conductors is likely due to the physical size and weight of larger conductors. Secondly, the building is a strip mall, so the actual load may vary depending on the tenants. It's important to monitor the load and adjust the electrical system as needed to ensure safe operation. The initial calculation shows that the 500 MCM conductors, with a combined ampacity of 1000 amps, appear insufficient for the calculated load of 1140 amps. However, NEC Article 310.15b2 allows for a 25% safety factor to be applied. When the safety factor is considered, the adjusted ampacity increases to 1250 amps, making the conductors adequate for the load. The reason that the power company is requiring the use of only 500 MCM conductors could be a physical constraint related to the infrastructure. They may also have limitations on the service entrance equipment or the available capacity of their distribution system. Strip malls can have fluctuating electrical demands, so continuous monitoring of the loads being drawn by the tenants is important. It is also possible that a clamp meter test could show a change in load based on time of day or usage during the year. The electrical system should be designed to handle the peak load to prevent overloading or damage to the equipment. If it is determined that the load exceeds the capacity of the installed conductors, upgrading the conductors or service might be required. The National Electrical Code is a set of standards for safe electrical installation and includes information on conductor ampacity. NEC Table 310.16 lists the ampacities for different sizes and types of conductors based on installation temperature ratings and installation conditions. The ampacity of a conductor is the maximum amount of current, in amps, that it can safely carry continuously under specific conditions. The safety factor, as mentioned earlier, is addressed in NEC Article 310.15b2. It is a provision that allows conductors to carry a higher load than their rated ampacity under certain conditions for a limited time. The calculation of the adjusted ampacity involves multiplying the conductor's ampacity by 1.25. This accounts for the 25% increase allowed by the safety factor. In this scenario, with the 500 MCM conductors, the ampacity is increased from 1000 amps to 1250 amps when the safety factor is applied. This adjusted ampacity is then compared to the calculated load to determine if the conductors are adequate. When determining the appropriate size of the service for a commercial building, it is necessary to carefully assess the loads of all potential tenants. A diverse tenant mix may result in a different load profile than one with similar businesses. It is important to design an electrical system that can accommodate the maximum possible load, even if it is not immediately present. Continuous monitoring of the electrical system can help to identify any potential issues early on, before they become major problems. Regular inspections and maintenance can also help to ensure that the electrical system is operating safely and efficiently. It is also important to consider any future expansion or changes in the building's use when designing the electrical system. Providing for future growth can prevent costly and disruptive upgrades down the road. Remember, the adjusted ampacity of the conductors should always be greater than the total load to ensure that the electrical system is operating safely and reliably.